everyone, my name is Timnit Gabru and I am a research scientist at Google. I co-lead a team called Ethical AI Team. It's a research team and I wanted to give this tutorial on fairness, accountability, transparency, and ethics also with Emily Denton, who is in the Ethical AI team as well. You might know her more from her work in generative models, but she's been also working in this area for the last couple of years. Before I start, I'm one of the few Black women I know in this field. In fact, I go to the conferences and I really don't see anybody. And I live in the U.S. I'm an immigrant to the U.S. So in the U.S., Black people are about 12% of the population, and globally, I would say maybe about close to 20% of the population. But when you go to conferences like CVPR or any sort of conversation about computer vision, academia, industry, anything, you don't really see us in it. And I've been talking about this forever, but right now it's actually even more difficult for me to do this kind of tutorial because I'm often in a place with nobody who looks like me or thinks like me, working in a field that really has done so many harmful things to my community. And so given all of the things that are happening in the US right now, all of the protests because of the murder of so many unarmed Black men and women at the hands of police, and actually the fact that this phenomena of white supremacy is a global phenomena. It manifests itself in many different ways in different places. In some places, Black people have the power to speak up because there is a quorum, there's a certain amount of people there. There are people who have studied the problem, who've written books. In other places, we're still struggling to make the connections. If you think about all of the things that's been done to the African continent by many European countries, there are many who just refuse to even acknowledge it. And colorism, which is related to white supremacy, is something that exists in basically all cultures and places that I know of. So even though so many things are happening to us in the world and a lot of the technology that we're creating here have done so much harm to us, there's really no representation. And I remember how painful this was in general. Like I remember when I was telling people about my experience with police, they just wouldn't believe me. They'd want to they would say stuff like, oh, they must have had a reason, or people would just want to counteract your explanation. And you can only do that so much if you're the only Black person around and people do this to you constantly over and over again. It's not really a great existence. I think people in the machine learning community at least are much more aware now because of the hard work we have done. It didn't happen by accident. A bunch of us worked really, really hard to work within the machine learning community. I unfortunately cannot say the same for the computer vision community. It is extremely very homogeneous and really almost doesn't have anybody who's Black, like very, very few people. So it's still very difficult to discuss any of these things, really, for me at least. And I'm, in one sense, I'm just very exhausted from trying to change these things in general. I don't really have it in me to now go into the computer vision community and do the kinds of things we did in the machine learning community. But I do hope that at least that some of the things that you've heard on the news might compel you to read more, might compel you to take this seriously, and maybe might compel you to understand how it's very, very related to the field that you're in and the work that you're working in right now. And before I start with this lecture, I would like to recommend a few people to read and watch. So for example, Ruha Benjamin gave a keynote at iClear. That's a very good introduction to some of the ways in which we should think about technology. She has a book called Race After Technology. Safiya Noble has a book called Algorithms of Oppression. Meredith Broussard has a book called Artificial Unintelligence. There are so many more I'm probably forgetting, not off the top of my head. But these are some that come to mind. Some people who've been working and thinking about this for a long time. Some Black women who are personally negatively affected by the technologies that we are building. Okay, so I want to start this lecture with a responses to a survey that we gave in Stanford's CS231N class. So we gave a similar lecture in that class, and the questions were. Where do you think this technology is being used most for today? And so we have some examples like assistive technologies, personal convenience, education, healthcare, etc. And so I think there's something wrong with our labels. There's policing and military, and so I actually think 40 people, 58% think policing, military, or is it personal convenience, and education, self-driving cars, etc. And then we also asked, where do you think the greatest positive potential for computer vision technology lies? And so many people said healthcare, self-driving cars, assistive technologies, agriculture. And then where do you see the greatest negative potential of computer vision technologies? 77% said military and policing applications, but for some reason we can't see the labels here. I don't know. I did something wrong, I think. And we wanted to ask people this question because we realized that many of us in research and applications don't really know what computer vision is mostly being used for right now. We have our hopes, we have our guesses. We kind of wonder about what the potential positive use cases could be. We speculate about the potential negative use cases, but we don't really have a comprehensive understanding of what it's being used for right now, and we think that's a very important exercise to go through. Someone who hasn't had issues maybe with surveillance or companies and things that mostly is used to the world around them kind of helping them, and might think that the greatest potential for this kind of technology is to adjust the environment around them according to their needs. On the other hand, someone who is used to being attacked or being surveilled constantly by their environment, when they think of this kind of technology, the first thing that comes to mind is probably not that they'll, not that this technology is going to help them, right? So that's kind of what we wanted to bring across here. That for the same kind of technology that's being built, depending on your experience, you might have different understandings, and your context, your understanding of what the pros and cons could be is different. So in this first part of the tutorial, what we wanted to do is just give a little bit of an overview of some of the things that are happening in the computer vision community and how they're affecting certain groups of people. And then, so we have a list of 3 lectures, and in the second one, we want to talk about data ethics specifically, because data is a big part of computer vision and machine learning and any data-driven technology. And in the third part of the tutorial, we want to talk about how researchers and practitioners can think through what kind of frameworks they can use to think through the pros and cons of their research, and that think through the ethical implications of their work. So here's one example. Faceception is a startup that claims to predict a number of things about people based on their images. And so for some people, they might think, oh, this is great for them. It saves them money. They can just look at someone's image and they can decide, oh, does this person have high IQ? Are they more likely to be a terrorist or a white-collar offender, etc. For some of us, we might think about all of the ways in which this could go wrong. For example, actually, I wrote a book chapter on race and gender and AI ethics, and even the test, the IQ test, is a highly racist test. Many people wrote about it even around its inception. I'm not going to go off much on it, but if you do read about the inception of the IQ test, I would highly recommend that you read it and wonder whether or not this is a kind of test that you want to use to hire people versus not hire people. And do you really believe that you can tell whether someone's a white-collar offender by looking at their face or not? So these are things that are related to the kinds of stuff that we are demonstrating and protesting against right now. Systemic racism, right? Because there is this understanding, this assumption that you look at someone's face and you can tell what kind of criminal they are. Like, for example, terrorists. Think about it. In different countries, there's an understanding of, excuse me, what a quote-unquote terrorist is. And it's certainly not, there is government-sponsored terrorism as well. And this kind of stuff, excuse me, is not to tell you about the government-sponsored terrorism. It's usually to single out people in different already marginalized groups as terrorists. This is another example of a startup, a highly successful startup that's used around the world called HireVue. They are used by many companies. They used to be used by Nike, educational companies, maybe even IBM, I don't know. I know they were used by the UAE government even. And what they do is, instead of sifting through thousands and thousands of resumes, they, by hand, recruiters doing this by hand, they have an algorithm that kind of basically does this in an automated way. And not only that, when you're interviewing for a job, then you are recorded, and the recording has emotion detection. And out of the emotion detection, they kind of see whether they say that they give the employer quote-unquote verbal and nonverbal cues of how you did with the interview. Now let's ask a few questions here, right? One is, let's say everybody uses this tool for everything. So your point of entry to applying for any job anywhere in the world is a tool like this, anywhere. And let's say it has a particular kind of glitch that assumes that, that you're always angry or something, or I don't know. That means you just might not get a job anywhere in the world for anything. And then let's think about determining internal state. What does it mean to determine internal state? Can computer vision really do that? So it's one thing to determine whether someone is smiling or not. I believe computer vision should tell me that. But when people are trying to think about internal state, like your emotion, am I happy or not? Do you really think that you can use computer vision to determine whether someone's happy or not? There's a lot of things people do, like criminology, whether someone's a criminal or not. We should really think through the implications of some of the things and who they are supporting and who they are harming and who they're funded by, right? So it's not people from marginalized communities that are advocating for these kinds of technologies. And also, we don't know what the characteristics of the HireVue are. So I said it might have a single point of failure, but it might not. It might not have a glitch. It might be, it might be violating things like equal employment opportunity laws. It might not. I don't know. But right now, we don't have a way to investigate it before it's unleashed into the world, right? It's not like the FDA, for example, in the US, investigates a drug for its side effects before it's unleashed into the world. And we need to have something like that for algorithms like this. So an example here is another example of the use of automated facial analysis tools is face recognition, which I guess recently has come under a lot of attention. So this one example, it's very sadly timely now, but this is an example of Baltimore police using extensive face recognition. On people. And so Baltimore, Maryland has one of the, so they say police in Baltimore County use face recognition on social media photos to identify people at the Freddie Gray protests. It's an unarmed black person who once again was killed by police. And Baltimore has one of the most invasive and one of the most extensive face recognition usages of face recognition. And it's right now, actually, a lot of people are saying not to share images of protesters on social media because many law enforcement agencies have dedicated people to look up their faces and match them to social media profiles. In this case, what they did was they used face recognition to identify protesters, and they linked them to their social media profiles, and then they would target them for unrelated arrests later. And this is clearly a form of harassment or retaliation, right? And it definitely discourages political participation. And there are many places in which face recognition is being used in this manner. In computer vision and in machine learning and related data science and related disciplines in general, we have a tendency to abstract out many things. And it's always very important to remember that most of what we're doing is related to people in some way, shape, or form. And so I really like this quote that Emily Denton actually found by Mimi Onuha from Data and Society. It says, every data set involving people implies subjects and objects, those who collect and those who make up the collected. It is imperative to remember that on both sides, we have human beings. In the next section of the tutorial, we'll talk more about this, but it's very important for us to remember this as we do our research. One project that I really like to highlight, because it's a project that really acknowledges that on both sides are people, like what Mimi said, is that it's called Our Data Bodies. And this project is led by 4 or 5, I don't remember if it's 4 or 5 women. And it's one of the few projects that I know that really highlights marginalized voices and works with the most vulnerable people. One of the leaders of this project is Sita Peña Gancadaran, and she gave a talk at ICML, at iClear 2020 just recently, at the workshop called Towards Trustworthy ML, the Rethinking Security and Privacy for ML. And Sita said that she said something like this, she said many other things, but I want to highlight this. The problem with abstraction, I've heard computer scientists present their research in relation to real-world problems as if computer scientists and their research is not done in the real world. I listened to papers that tended to disappear people into mathematical equations. She's actually talking about a conference she was heavily involved in last year, and a conference which I helped start as the founding executive member. It's called FACT. So it's short for Fairness, Accountability, Transparency, Socio-Technical Systems. And this is a conference where it's an interdisciplinary conference in computing focused on working on issues of fairness, accountability, transparency, socio-technical systems. And, so all the people that she's talking about are self-selected. There are already people who want to work on this issue and who already want to work in an interdisciplinary manner. But even among these people, there was a huge amount of abstraction. And one of the things that struck me that she says is that marginalized people are demonized, deprived. What is the point of making data-driven systems fairer if they're going to make institutions colder and more punitive? And this is a good segue into an example, actually even from my work, and it's the way in which the community responded to it. In some ways shows that there is a drive to make data-driven systems fairer, quote-unquote fairer, by having maybe like more diverse data sets or something, without really thinking about how these systems are actually being used, even if they work perfectly, quote unquote, as envisioned by the designer, how they affect those in the most vulnerable group. So this work is called Gender Shades, and it was released in 2018. So Joy Buolamwini, who is the lead author of this paper, and actually this was part of her master's thesis, and I showed that there is a high disparity in error rates, and the highest disparity is among lighter-skinned men and darker-skinned women on APIs with automated facial analyses tools. And so specifically in this case, we analyzed gender classification tools, APIs. So these are APIs you have to pay for, right, from these different companies. And what these models do is they look at a picture and they classify the person in the picture as male or female. That is binary. So if you flip a coin and guess, then of course you do this with a 50% accuracy. So at the time, Facebook and IBM almost reached this random chance. And now, of course, the results are different because IBM has changed their model after these results. Now, there was a number of things about this work. First is that people had done this kind of analysis by race, but we know that race is a social construct that is unstable across time and space. So for example, like, who's considered a certain race here in the US is different from Brazil, let's say, it's different from South Africa, it's different now versus, even the US. The categorizations in 1895 were very different from now. Even let's say in South Africa, during apartheid, for example, Chinese people were classified as black and Japanese people were classified as white, so race is really a social construct. Of course, it has resulted in many discriminatory and deep-seated issues of inequity, but that does not mean it's rooted fundamentally in biological facts. So for this specific study, we decided to use skin type, what we call the Fitzpatrick skin type classification system, and we looked at lighter versus darker skinned people. And so when we were doing this analysis, we thought that the first thing we could do is just look at publicly available data sets, because there's been so much work on automated facial analysis tools. And so we looked at data sets like LFW, IJB-A, ADNs, and we thought we could just label them by skin type and gender and do our analysis. But we found that these data sets were overwhelmingly lighter skin and overwhelmingly male. So we actually had to create our own data set called the Pilot Parliamentary Benchmark, which was more balanced by skin type and gender for our analysis. So many works have since shown that there is an issue in the data sets that we use in computer vision, the issue of diversity along many lines. So this work shows that the COCO benchmark looks at the distribution of COCO benchmark versus the world population. and how that results in the fact that object recognition does not work in many different places. Other works show the way in which bias in the training data can be amplified. So this is an example from, again, the first work on does object recognition work for everyone. This is another example where you see that the notion of couples or weddings is heteronormative and Western, right? So for example, the people who are not at the very right, who are not in a Western setting, are not classified as being in a wedding, whereas everybody else basically is. So here, let me see just how I am on time. So confused when I look at the recording. So here we can see that this is not an AI specific problem, right? This lack of diversity of data sets. So for example, there are many works that talk about how when people did crash tests for cars, they used prototypical male dummies with prototypical male characteristics. And so that means that a lot of these cars ended up killing women and children disproportionately during accidents. Similarly, clinical trials were not really tested on women, and so a lot of these 8 out of the 10 drugs that were pulled up the market very recently, actually, maybe like in the late 1990s or early 2000s or something like that, disproportionately harmed women. So I'm glad to see that, 2-3 years ago, there wasn't that much discussion on fairness, accountability, transparency, and ethics in computer vision at all. And like even when we were working with Joy, I think it was kind of difficult to explain to people in this community why what we were doing was important and what was the importance, what was the significance of what we were doing. But I think that now a lot of people have understood that we need to have more diverse data sets. But unfortunately, I feel like that's kind of where the understanding has stopped, right? It's like it's basically like, let's diversify our data sets, and that's basically kind of ethics and fairness, right? But you can't ignore social and structural problems. So in this example of gender shades, a lot of things happened in results to this work. One is that, for example, IBM came up with this diversity in faces data set, but then they had to take it down because the data was taken from Flickr, like many of us in computer vision do, because it's a big source of data, and like for convenience we take from it. But imagine someone who puts their picture up on Flickr like 10, 20 years ago or something. Did they put it up on with the assumption that it was going to be used to train face recognition models that might be used by Baltimore police to then identify protesters and then target them for arrest somewhere else? So then IBM had to take it down. And then Google took this understanding that we need to have more diverse data sets, and so they started looking for darker skinned people to evaluate the pixel camera, right? And then of course you see this headline that it was more predatory way in which they were looking for darker skinned people. Then people thought, oh, we don't have a lot of transgender people in some of these data sets. So then transgender YouTubers were having their images scraped from YouTube without their consent. And then finally, Microsoft, came out with an automatic gender recognition system that didn't have those high disparities in error rates that we showed in gender shades. And so they were like, we fixed it. We fixed our, gender recognition system. But in all of these, we forgot that many people had actually written about the harms of gender recognition systems, that the harms that these systems can cause to many people, especially people in the trans community. So I suggest that you read some of these works. So from, why would you have to ascribe gender to someone? What is the reason that you need to do this, right? And what about misgendering? I mean, how can you, it makes the assumption that you look at a person's face and appearance and you can ascribe gender based on that. It also makes the assumption that gender is binary, makes the assumption that gender is not culturally dependent. Gender presentation is not culturally dependent, is something that is stable across space and time, similar to what I was talking about, race, which is a social construct. Gender is also a social construct. And also the other question is, why would you need to do gender recognition in the first place? Many times people use it for targeted advertising, for example. And so is it really good to try to infer that someone's, let's say, a woman, so that you can advertise products that you think women should use? That can perpetuate gender stereotypes. So the point of this was that making something fair is not just about making something work equally well on everybody. I think at first we were just trying to have that conversation, and now I feel people kind of understand that you need to have more diverse data sets, et cetera, et cetera. But it's not just about making something work equally well on everyone. It's sometimes, even if you have a task that works equally well on everyone, it's still bad, right? Like the face recognition example that I just gave from Baltimore police. If it works perfectly well, it's still bad to target protesters that way. And sometimes a task just should not exist, like this gender recognition. If you read some works, especially from people in the trans community, you will see why automatic gender recognition tools are harming people in the trans community. So here's an example of, again, making mistakes while trying to diversify data sets, right? Not making mistakes, but this is not making things fair, right? So here, they needed more African faces, and now they're harvesting more African faces, but that's not necessarily in order to benefit the people whose faces are being harvested. And we don't have to go to China. In the U.S., there is an extensive use of face recognition by law enforcement, and most of the people who are surveilled and negatively affected by this technology are, of course, Black and brown communities, immigrant communities being targeted by ICE, immigration custom enforcement agencies, etc. So, for example, this study called the Perpetual Lineup by Claire Garvey, Alvaro Badilla, and I forgot the first name of this person, Frankel, shows that 1 in 2 American adults is in a law enforcement face recognition network. And at that time, as they could use it for unregulated searches, employing algorithms with unaudited accuracy, right? So when me and Joy showed in our work that there were error rates, the high disparities in error rates, at this time there was nobody was required to talk to the public about what they were using these systems for, what systems they were using, and what their accuracy was. And so when they first came up with this study, they asked for a regulation on face recognition in the United States. And in fact, they didn't ask for a moratorium, they asked for a regulation. More recently, the same team came up with this paper called, not paper, but report called America Under Watch. And part of what they talk about here is that, and so after this report in 2019, they actually now have asked for a moratorium. And so what they were asking, one of the things they were describing, for example, is how many times this technology is not even used in the manner that it was designed to be used. So for example, people in law enforcement would put composite sketches as probe images. That's not what you're supposed to do. You're supposed to have an image of a person. They would say that they think that a suspect looks like Woody Harrelson, so they would take an image of Woody Harrelson, who is a famous actor in the United States, Photoshop his eyes, and put it into the system to retrieve nearest neighbors. Why is this a problem? Because in addition to heavily surveilling certain groups of people, even perfect face recognition could be, obviously is used in a manner that negatively impacts certain groups of people. But flawed face recognition, when it's used like this, can result in infringements of even more civil liberties. And in fact, coupled with what we call automated, what is it called? Trusting algorithms too much, right? Automation bias. It could be even more catastrophic. So for example, people like Laura Moy of this study have talked about how they suspect that sometimes these kinds of tools have been used as evidence in the court against certain suspects. So like people would trust what this tool gives them back as who the suspect actually was. And despite, even if this person does not really is not really the suspect, just because the tool is telling them something, they can believe the tool just because it's an automated tool, and send the wrong person to jail. So this notion of automation bias is very important. And actually people like Ayanna Howard at Georgia Tech had done the study a couple of years ago showing its impact. So what she did was she had a group, so they had a study where they simulated a fire and smoke, and they had a robot that was guiding people to different directions, and people just ended up following the robot in so many different directions that just didn't make sense. The robot would guide them towards the smoke, and people would just kind of follow it towards the smoke. And if I was guiding you towards smoke, you would ask me why I'm going towards smoke. It doesn't seem like a good idea to do it. We should probably move away from the smoke. But because it was a robot, they just followed it around. So the combination of automation bias, balance of power in these tools, and surveillance can be very catastrophic for people in vulnerable groups who are constantly surveilled and under watch by these technologies. So I guess I've discussed face recognition a lot because it has recently been discussed a lot, and my own work has focused on it. And it's very, very clearly related to people. And many times, though, a lot of the things we do in computer vision are not very it's not very obvious how they're related to people. But even things like face recognition, right? It's not always obvious whether something is harmful or not. So many people kind of ask, why am I so worried about face recognition? People can recognize faces. What's the problem with face recognition? It's not like killer robots or something. Remember that killer robots are, first of all, they are composed of various things, of which face recognition can be one, right? And we should remember that technology only amplifies our intent, what we're able to do. So, for example, we may recognize people, but we can't recognize 6 billion people, and we don't have the memory to remember all of them and pull up all sorts of past information about them and put 2 and 2 together. But that's what these networks of face recognition tools can do. So to give an example, this is an article from Life magazine during World War II in the US. And my co-author of one of our papers, Un Seo-jo, who's a historian at Stanford, found this and showed it to me. And this is basically showing an illustration of how to distinguish a Japanese American from a Chinese American. And why do we care about distinguishing Japanese Americans from Chinese Americans? Because at the time, they wanted to target Japanese people, but not Chinese people. Right now, this kind of targeting by facial characteristics, right, of different groups of people is actually happening in an automated way across the board, right? So is this really kind of how we would like our technology to be used? Many times, the groups of people who are marginalized and who are the recipients of said technology and the recipients of such marginalization and such surveillance are unfortunately not part of the dominant group who benefits from selling this kind of technology. And they are also usually not part of the dominant group who works on this technology. So for example, who are the kinds of people who are pushing facial recognition to police, right? And who are the people who are actually working in this technology? So this is a picture of iClear. I think, I don't remember if it was 2018 or 2017. Unfortunately, it was supposed to be in Ethiopia this year, and it was going to be the first time that was going to be held in Africa, so I guess the room would have looked very different. But when I look at this room, I don't see anybody who looks like me in any way, right? I don't see anybody who currently is representing my interests. It's a room full of, lines and lines and rows of men, mostly men. I don't really see women here. Maybe there's a couple. And mostly white and Asian men. And like no black people at all. And of course, I've been talking about how black people have been the recipients of negative technology like this. And so why do I want to talk about this? Because like I said, we can't ignore social and structural problems, right? So, and by definition, most of the people who are marginalized are not in the dominant group that is benefiting from the creation of this technology. So as important, I don't really see my research kind of divided into technical and social, right? So one of these people who was felt the same way as I did, walking into these kinds of rooms constantly. One of these people was Deborah Raji, and you can see her picture here in the New York Times article. And why am I bringing her up? Because Deb wrote a follow-up paper to Gender Shades, the paper I talked about that we wrote with Joy, showing disparities in error rates between lighter-skinned men and darker-skinned women, in automated facial analysis tools. This was a follow-up paper showing that Amazon's recognition tool that is being sold to police actually has the same types of biases. And once this paper was released, VP after VP tried to attack, excuse me, both Joy and Deb try to attack this work. And my co-lead, Meg Mitchell, and I actually worked for one whole month to bring together a group of computer vision researchers and write an open letter to Amazon describing the technical details of the work and standing by the work and calling on Amazon to stop selling recognition to law enforcement. I wanted to highlight this whole story because Deb told me that before she came to Black in AI, so Black in AI is a group I co-founded with my colleague Redit Abebe. So Deb told me before she came to Black in AI, she was ready to quit the tech industry out of isolation, marginalization, discrimination, and all the rest. And she said that once she found Black in AI, she was supported, she was thriving, and she felt comfortable to be unapologetic in who she was. This is very important because people like Deb took risks, right, to write papers attacking a big company, and they put their careers on the line and worked on problems that disproportionately impact their own community. So it's really important to think about representation beyond diversity of data sets. We have to have structural representation and real representation. Right now, there is a lot of talk about ethics panels, ethics boards, ethics codes, and all of these things, ethics centers and ethics, many things related to ethics. But many of these boards and panels and centers basically only represent people in the most dominant group and the most powerful group, and people who are the closest to the money and people who are closest to the dominant group. They're not representing the people that were highlighted in projects such as Our Data Bodies, for example, homeless people who couldn't find housing because of databases, people who were wrongfully convicted of certain crimes, etc., etc. So I think my take-home message here is fairness is not just about data sets, it's not just about math. Fairness is about society as well, and as engineers and scientists, we can't really shy away from that fact. In fact, if you would like to read a short, well, I guess it's a long paper, but it would be a short book. It's like about 40 pages or so. It's called The Moral Character of Cryptographic Works. I'm sorry, The Moral Character of Cryptographic, I forgot the other title, by Philip Rogway. And he talks about how the cryptographic community abstracted away its work so much that it failed to prevent mass surveillance. And he puts it on the cryptographic community, that failure. And he talks about how other scientists, for example, physicists, were active in nuclear disarmament, and how this detachment by the cryptographic community has resulted in the kinds of issues that we see today. And I would like to make a similar call to the computer vision community to understand just how pervasively our technologies are being used to marginalize many groups of people. Finally, I want to talk about how people are combating this technology, right? And so, for example, for face recognition, I saw a really interesting video, for example, of Russian protesters wearing interesting face makeup that fools face recognition. I mean, I even saw research where they made real-life adversarial examples from CMU, where they would train again they can basically print out, 3D print out glasses with constraints to make it such that the glasses don't look too conspicuous, in order to fool a face recognition system into thinking that you are actually another person. There's also all of this fashion that people have to wear, that is used to fool face recognition systems. So many times when people create these kinds of systems, other people also come up with what Sita calls systems of refusal in engaging with these technologies. I'll talk more about what Sita says, examples of refusal while engaging with technology, especially in the data ethics section next. But I just wanted to give an overview of some of the problems in computer vision. These are definitely not the most comprehensive, but especially right now, I think it's very important for people in our community to understand how our technology is mostly being used to target the very people who are most vulnerable in this society. In the third section, Emily is going to talk about what we think researchers should do and give different kinds of frameworks to think about ethics and fairness and accountability and transparency in your work. And in the next section, we'll talk more about data ethics. Thank you.